Well, we've made it. We've made it to hyperbolas. So hyperbolas, remember, are the conic section that look like kind of like two parabolas that are facing opposite directions, but they look like this. And we're going to need a few important things. We're going to need the vertices. The vertices are going to be, if it opens left to right like this, they're going to be at plus or minus a, and we'll talk about that in a second. This is just a lot of information, but there are a few important things that I want to show. We do have a center, and the vertex is that a distance away. Okay. We also have a b value, just like we did with ellipses, but that b value is telling us how far away it is on this, what they call the conjugate axis. And then we do have these asymptotes that go from one diagonal to the other. They are the diagonal asymptotes that we'll look at. And then the final thing is the foci. So here's what you need. There are two different ways to write the equation of a hyperbola, and it's going to come down to, is it opening up and down or left and right? And so here, this equation that we just looked at was one that opened left and right. And so if I were to write the equation of that hyperbola, it would be like this. Now with ellipses, we switched the a squared and the b squared, but with hyperbolas, we switched the x squared and the y squared. A squared will always be first, and it is possible for a squared to be bigger than b squared. It won't be always, but it is possible. So with the y squared first, that means that it would open up, down. So I just kind of remember it that whichever variable is first is the direction that it opens. And I'll usually make a little note to myself before I start. Let's jump right in. So graphing with hyperbolas, the first thing that I'm going to do is find the values of a and b. So actually the very first thing I'm going to do is say y squared is first, so it's going to open up and down. Okay, that's just a little note to me. So a is going to be the square root of 16, which is just 4. B is going to be 3. And I'm going to graph these. Now, this 4 is underneath the y squared, so I'm going to go in the y direction. I'm going to go up 4 and down 4. And in the x direction, I'm going to go left 3 and right 3. Now, you might be thinking, wait a second, this looks like an ellipse. But here's what we're going to do at this point. This is where things are going to change a little bit. I'm going to make a rectangle with these points. And then I am going to draw, remember we saw those asymptotes on the first slide. I'm going to draw the asymptote, the diagonal asymptote that goes through these points. Now, I said that my graph has to open up and down because the y squared is first. So this is the fun part. I'm going to start at the vertex, and I'm just going to draw a graph that gets close to that asymptote, but never touches. Oops. Okay, I kind of touched there, but that's okay. I didn't like blatantly cross it. We'll use some grace there. All right, guys, that's graphing a hyperbola. So you're going to draw this little rectangular box, draw the asymptotes, and then you've got your guidelines. So let's try another one. Oops. All right, so the problem with this one is what? The problem with this one is that it's not in standard form. It's not like, it doesn't look like either of these. So I'm going to change it. How could I change this equation to be in standard form? Well, to be in standard form, I know that it needs to equal 1. That's one of the key things. So what I'm going to do is I'm going to go through and divide everything by 64. And what that does is it gives me x squared over 16 minus y squared over 4 equals 1. All right, that looks a little bit better. That looks like something I can work with. So first of all, which direction is this going to open? Because x squared goes first, it's going to open left and right. Then it says to find the values of a and b. So what would our values of a and b be in this problem? A would be 4 and b would be 2. So we're going to graph those. In the x direction, because 16 is underneath the x, I'm going to go 4 and negative 4. In the y direction, I'll go 2 and negative 2. And then I connect those points with a rectangle. All right, next up is to draw the asymptote. All right, and again, I want this opening left and right, so I'm going to start at my vertex right here and get close to the asymptote without touching it. Start on this one. There you go. Guys, hyperbolas are the best. I love this. So when you're finished with this, I should see a rectangle as your guideline. I should see those asymptotes and then your hyperbola opening the correct way. All right, so we've talked about foci with ellipses, and foci with hyperbolas we're just going to use the Pythagorean theorem. So remember with ellipses, it was a squared minus b squared, and I said kind of the way to remember it is do the opposite sign. So since a hyperbola is like x squared or y squared minus the other variable squared, I'm going to do the opposite sign here and just do a squared plus b squared. All right. Find the foci of the graph. So I already have a squared and b squared. So I'm going to put 36 plus 4 equals c squared. That means that I would have 40 equals c squared. And then I want to take the square root of that. And if I take the square root of 40, I should get something like 6.3 maybe. Yep. But just like yesterday, we want to actually write the equation of those foci. And so we're going to have, which direction is this one going to open? It's going to open left, right, because the x is first. And so that means that my foci need to be on that same axis. And so that means that I'm going to have this. So if I put those on my graph, that's going to look like this. And what should happen now is, remember that the foci should be kind of inside that hyperbola, so it should open up around the foci, kind of like the parabola did. So now, help me out. I need a and b values. What am I going to get for this one? I'm going to get a equals 6, b equals 2, and I'm going to put those points here and here. There we go. Next up, I'm going to draw those asymptotes. That one was not a great asymptote, but I drew some other good ones. All right, and then my last step is just to draw the hyperbola opening, getting close to those asymptotes and opening up around the foci. There we go. That's it. All right, so for this problem, I would like you to start by finding the foci. All right, so finding the value of the foci, you should get 5.83. Which direction is this hyperbola going to open? It's going to open up or down, up and down, I should say. So that means that the ordered pair for the foci would be what? It would look like this. So I'm going to have focus there, and I'm going to have a focus there. Now, A and B values are what? Whoops. A is 5, B is 3. So drawing that box. All right, and next up are the asymptotes. So this is why I really like this unit. I think it's just kind of satisfying to draw these guidelines, and it's not graphing with a table. It's just saying, draw these guidelines and then draw something that fits inside of it. It's kind of fun. There you have it. That is a hyperbola with the foci 0 plus or minus 5.83. As always, let me know where you still have some questions or concerns.